Hello everyone, and thank you for your interest in Danomics. My name is Cameron Snow, and I'm one of the co-founders of Danomics, and I lead the subsurface development of the platform. So Danomics is a cloud-based subsurface interpretation platform that is focused on petrophysics, geoscience, and decline curve analysis. And our mission is to provide you with the tools and methods you need to quickly make high-quality interpretations across thousands of wells. And we want you to be able to do this fast. One of the main reasons we started this company was because the compute times in legacy software solutions for projects with a few thousand wells is often several hours to even days, which means that the iterating and experimenting process that we need to do as technical staff to get to the best answer is just too painful. And that's why we wanted to reset expectations on what fast means. And although Danomics is a fully commercial and ready to go solution, we're still evolving. We only launched in late 2018, early 2019, and since then we've released over 150 updates and we've launched 3 product lines. So right now we have solutions for petrophysics, decline curve analysis, and geoscience. Petrophysics is where we've had the biggest impact so far. And although our platform can do high quality single well interpretations, its real strength and value add comes through the fact that it was explicitly designed to handle interpretations at scale. What this specifically entails is bringing together a combination of automated processes, carefully applied machine learning methods, and building in a layer of spatial awareness so we can better propagate interpretations across a play. The decline curve analysis tool automatically declines out every well in your data set while giving you the option to perform manual tweaks as necessary. And it also includes economic evaluation so you can understand both the recoverable volumes and the economics as well. Geoscience is something that we have been pushing into quite hard at the moment. We've already got what I think is one of the best cross-section tools available on the market right now, as well as some basic mapping. By the end of Q1 next year, I fully expect this to be an area where we can meet or exceed the offerings of many of the legacy softwares. And by the end of next year, I fully expect us to have also pushed into 3D property modeling and/or seismic interpretation. So when it comes to the value proposition, we see 3 ways that Danomics can help create value for your company. The first is cost. We have a low-cost annual subscription model that prices our software at or below what your annual maintenance cost would be on your existing softwares. Also, moving to the cloud means that you don't need expensive desktop machines. The software can run just as well on a low-end laptop as it can on a high-end desktop. The second is productivity. At our core, we are fundamentally a productivity tool. Unfortunately, the industry has had to cut headcount, which means that you need everyone to be able to do it more and do it faster. There are a lot of ways we do this, and speed is a big one. Our testing has shown that we can do the same calculations 30 to 50 times faster than our competitors. So instead of calcs taking a whole day, they can take 15 to 20 minutes. We also run calculations in the background, so kicking off a big calculation doesn't mean that you've tied up a computer or a license for a whole day. You can keep on working. And the third way we add value is through giving you the tools and methods you need to make better interpretations. Right now, I'm betting that there is a disconnect between your petrophysicists and your G&G staff, and that's caused by the fact that the petrophysics tools don't allow them to scale up their interpretations, while the G&G tools don't give them the sophistication that they need. We're eliminating that trade-off by letting you make those detailed zone-by-zone interpretations at scale while applying a best-in-class workflow. So we are cloud-based, and this wasn't something that we just did for fun or for marketing value. Cloud allows us to deliver more value to you. So first of all, cloud is scalable, so thousands of wells aren't a problem. We can call up nearly infinite compute as needed. Cloud enables collaboration, and this is something we're really looking to expand on in the subsurface. And cloud also enables us to develop faster. So we can get updates and fixes out to you, and the only thing you have to do as a user is refresh your web browser. So as I mentioned, we view being natively multi-well as being extremely important. So what does natively multi-well mean? It means more than just being fast. It means that we do things like get all of your data ready to be interpreted without you having to spend hours fretting over units or curve names. It means giving you a combination of automation and manual control over your interpretation so that you can turn your data into knowledge. It means being spatially aware so you can pull data in from maps or interpolate parameters from other spatial databases. What it doesn't mean is being a black box. We give you the ability to visualize and interact with your data with maps and cross plots and log plots and cross sections. And so since seeing is believing, what I want to do now is spend just a few minutes in the platform showing you what it looks like in action and how we make some of these interpretations. So the first thing I want to show you is how easy it is to get your data interpretation ready in Danomics. This is a crucial first step when working with large data sets, as you need clean and consistent data at the start. In Danomics, all of your data is automatically aliased, checked for curve units, put in the correct lithological reference, and data from multiple runs is composited together. This all happens without the user having to take any action. The next step in data prep is curve normalization. So let's say that I want to normalize my gamma ray curve. I'm just going to come here, select the method that I would like to use, and now this has been automatically applied to every well in my data set. I can QC this via a cross section. And when I look at my cross section, I can zoom in here on my area of interest, and we can see how our gamma ray curve has been affected. So we can see that some wells have been shifted higher and some wells have been shifted lower. Now the next step in my interpretation process is to evaluate areas where we have some washout and where the curves may need to be repaired. So here we can see the density curve is quite washed out. So what I'm going to do is I'm going to turn on some of my options for flagging bad hole, and I'm going to instruct the system to automatically repair my density curve. What's happened is behind the scenes, several machine learning models have been built automatically, and then the best one has been selected and applied to repair my data. So now at this point, our data is ready to be interpreted. Okay, now that our data is interpretation ready, let's take a look at how we actually perform the interpretation in Danomics. So let's start off with the clay volume, for example. So for clay volume, we have a number of methodologies that are available to us. For setting the parameters on all of these, we've set it up so you can drag and drop parameters, and you can see how these curves change immediately. You can also enter values into the text box, or you can change your parameters via crossplot, also via drag and drop. As you do this, you can see that the changes take place immediately. Once you've done this, let's take a look at the inversion, for example. So for our mineral inversion, we can come in here and we can choose what curves we want. We can also select the minerals that are available in our mineral mix, and we can do this on a zone by zone basis to create as much granularity in our interpretation as we'd like. And then we can QC the results of the quality of our fit using the built-in log plots. Once this is done, we can do additional QC via things like maps and cross sections. So let's take a look at a map to see how the results look. After a brief period, we see that our map has finished and updated, and we can now QC our interpretation and explore what is driving some of the results. Once we've done this for all of our interpretational modules like the TOC analysis, porosity, saturation, and cutoffs, we're then ready to move into some of our more advanced functionality like evaluating pore pressure and geomechanics. So once you've wrapped up your basic interpretation within Danomics, you may want to explore some of the more advanced functionality for your wells. So let's say we wanted to look at rock strength and wellbore stability. So we could start off by modeling out what our shear wave response should be if this is a well that doesn't have one, or we could choose how to do the model via Greenberg and Castagna, for example. Once we've established that correlation, then we could take a look at things like pore pressure, where we could use the Eaton sonic and resistivity methods to establish our pressure profile and to identify potential areas of overpressure. Once we've done that, we could take a look at our 1D geomechanical earth model. We'd select our correlations to determine our rock strength, calibrating that to core data if we had any, and then we could evaluate our mud weight windows that will allow us to drill the well safely and without problems. So hopefully this gives you a feeling for some of the more advanced functionality that we are building into Danomics, and lets you see how we are trying to help you add value above and beyond evaluating reservoir properties. So I hope that the demo of some of the software capabilities that I just showed you has whet your appetite for taking a closer look at Danomics. If you'd like to get started with us, there are two ways to do that. First, we've had a great relationship with our two existing development sponsors while building out the Petrophysics and DCA tools, and we're looking to add additional development sponsors as we move forward with development. So if your organization has an interest in forming a longer-term strategic relationship with Danomics, consider coming on as a development sponsor for the next phase of the build-out. We're very excited about what's to come, and right now our plans include more geoscience tools and 3D property modeling, seismic interpretation and integration, and the ability for users to run their own custom code on top of Danomics data management capabilities. The other way to get involved is by getting on the platform. We've got it set up so that you can get started yourself. Just go to www.danomics.com, and on the homepage you'll see a link to create an account and get started on a 30-day trial with no strings attached. And we'll help you get up and running and provide you with full support to make sure that you get the most out of your trial. And if you have any questions, please feel free to shoot me an email at csnow@danomics.com. Thank you.